David Can here with another question from your Hayes and Harris Math SL textbook. This is Chapter 1C, Question 3G. In this question, we're asked to find the domain and range of this function here. The domain is all of the possible values of x for which the function has a reasonable meaning, and the range is all the possible values for our y variable, or f of x, for which the function has some sort of reasonable meaning. So, in order to see if there are any places where this function doesn't make sense, we need to look for ways in which this function might break down. And the first thing that I see is that we have a square root in this function. And as long as we're ignoring things like imaginary numbers, you can't have the square root of a negative number. That's not meaningful to us. So what that means is whatever's inside the square root must be positive. So I'm going to say that 2x take 5 has to be greater than 0. That's a rule that I picked up out of this equation. If 2x minus 5 is less than 0, if I have a negative number under the radical, then the function doesn't make sense. Now I can solve this. I'll move the 5 to the other side. That means 2x must be greater than 5. And I'll divide by 2, which means that x must be greater than 2.5. This gives me an indication of what values for x make sense. Only values for x greater than 2.5 make sense. Anything less than 2.5 or equal to 2.5, and I'd get something here that was troubling. I guess if I had exactly 2.5, then what I would get is 5 take 5, and that's 0. Square root of 0, I guess you can argue about, but let's suppose that's 0. That's also a problem, because then I have division by 0. 3 divided by 0. So I don't want x to be 2.5 exactly. I need it to be greater than 2.5. And that's what my domain is. My domain, then, is the set of all numbers described by this variable x, where x is greater than 2.5. There's my domain. Using my domain, I can state the range now. The range being the values for the y variable. So I'll say that the range is the set of values I'm calling y, which consist of values which are, and let's find the rule. Well, x can only be greater than 2.5, so I can only plug in 2.5 or more here, which means I'm only going to be taking the square root of positive numbers, and the result is going to be positive. There's an implicit positive sign right here. So I have a positive on the bottom and a positive on the top, and it's always going to be that way. No matter what value I plug in for x, this radical is always going to result in a positive result. So I always have positive divided by positive. That's always positive. So the overall result here is always positive. So my y variable, or my vertical variable, f of x, can only be things which are greater than 0. They can only be positive values. We can see this if we graph the function. So let's scroll down. I've got the graph. This is the graph of the function. F of x is 3 over the square root of 2x take 5. And we can see from the graph that right here, there's what we call a vertical asymptote. The function doesn't cross this line. It just gets closer and closer and closer to it. And what that means is that along my x-axis, I can only make sense of variables which are greater than 2.5. So x must be greater than 2.5. The function doesn't have any meaning over here. There's no value for it. And I can see that the function also drops down to what appears to be an asymptote right above 0. So on my y-axis, I have values only which are greater than 0. I see values for the function over here, but nothing below it. So there's greater than 2.5 and greater than 0.